So in this video, I'm going to show you how to program your TI-84 calculator. And what we're going to do is we are going to program to do some numeric integration. So I'm going to use this as my function just to test because I have the values worked out by hand so that we can check the programs. So I'm going to show you, I already have the midpoint formula programmed in. I'm going to show you that. And then together we're going to go ahead and program the trapezoid rule. So your calculator, I don't know if you've noticed the button before, but kind of here between the stats and the VARs button, it says program on it. So that's what we're going to start with. So program, and then you'll see I already have 3 here. Well, only mid is all set up. So that's my midpoint program. So that will calculate the midpoint. And let me show you how it works first. So yes, we're going to do the program that does midpoint. And look what it's doing. It's asking me, what is your n? And remember, n is the number of intervals you want. So the answer that I have deals with n equals 8, right? And then remember the example we're doing from 1 to 5. So a is 1. It's asking me for b. B is 5. And it tells me what the midpoint approximation is. And that is exactly the number that I got when I did this by hand. So let me show you what that program looks like. So to see the program, we're going to hit program again. So again, that program button. And now, while it's highlighted on midpoint, I'm going to go over here to edit and hit enter. So here's what it does. So the first thing it did was it cleared the home screen. So it gave me a blank screen. And then prompt N, prompt A, prompt B, right? That's where it asked me to input those values. Then it took those values and it did b minus a divided by n. So what would that equal? Exactly delta x. So what I need to keep a hold of that number because I'm going to have to use it later. So I stored it using the arrow into a new variable d. So d is holding my delta x. Okay. This 0 into s, that is just initializing our s. So the variable s for me is going to hold all of my summation. So before I get too far, let me remind you what the midpoint formula, midpoint rule does. So to use the midpoints to approximate the area under a curve, you take the width of the rectangles, so delta x, and then these are, right, the sum of all of the heights of the rectangles, where the c sub j's are the midpoints for each chunk. And then here's a formula here, c sub j equals a, your starting point, plus j minus 1/2 times delta x. Those gives you, this formula here gives you those middle x values in each of your intervals. Okay. So let's find that here in my program. So as you go through, so this for loop that I have, this is doing all of those internal height calculations for me. Okay. So a for, it's like it does this process for all of the j's between wherever you start, and I'm going to start at 1 up until n. So this next line, I'm going to take a plus j minus 0.5 times d. You'll notice that looks just like that c sub j that I just showed you. I'm going to do that, and I'm going to store it into the x variable position. Okay. Then I'm going to take y1, just from your y equals screen, add it to s that we initialized up here, and then store it back into s. So that's adding on all of those heights as you calculate each one. And then end is just the command that stops that for loop. And then my final thing down here is where I display my answer. So display and then s, that's sum, right, all of those f's that we added together, all of those heights, times the delta x. So that's the midpoint rule. So now let's go ahead and we're going to program the trapezoid rule. So before we do that, let's take a look at what that one has in it. Let me zoom up just a little bit here. So the trapezoid rule, it's 1/2 delta x, and then my start and my end, they only come in once, but all of those interior heights happen twice. So you can think about it, right? This f of x sub 1, that's the height for both the first trapezoid and the second trapezoid, so that's why it shows up twice. And then all of those x sub j's are just a plus j times delta x. Okay? So let's see if we can create this. And again, I know what answer I'm looking for, so we can check it and go back and correct it if it's not. So one thing about the program menu, go back down so you can see a little bit better, is you have to exit out a lot. So we're going to go ahead and quit and then go back into the program. Now, I've already been practicing this, so I have mine all set up with Trap, and I've deleted it. We're going to make it again. But you're probably going to want to create a new one. So you're going to go from the first program menu over to New, and go ahead and hit Enter, and then you can name yours. I need to just edit mine. So I'm here. I'll wait until you get yours. Once you get to the Create New, you'll notice that your cursor is flashing with an A, so you're in alpha mode. So go ahead and find your alpha letters down here, right on your keypad, and name it something. And then you can go back and program edit. So here we go. So the first thing I want to do is just what I did before. Let's go ahead and clear our screen. So now when you hit program, notice that you get a different menu. So the only two parts that we're going to use are Control and I/O. So the I/O stands for input, output. Control, these are going to do a lot of your basic, like your for loop. That's where we're going to find it. So I'm going to go over here to input, output, and notice 8 is clear home. And again, that's just to make it look pretty. You do not have to have that as a thing. Okay? And then next thing, we want to prompt for, right, the N, A, and B. So prompt is, so hit program again, and then input, output. So we want some input from our user. So item 2, prompt. So let's prompt for N. So find your letter N, so it's on your log button. So first you hit alpha and then N. And I don't have to do the N in quotes so that it shows up. It automatically prompts for N with a question mark. Do the same thing to get your A. So program, input, output, prompt for A. Oh, shucks, and I hit the wrong button. Okay, so back into program, input, output, prompt. Oh, I've got too many prompts. Delete, prompt, A. There we go. And then program, input, output, prompt, B. Okay, so I have all of those. So now we need delta X. So go ahead and do delta X. So we're going to type in the formula. So it is B minus A, parenthesis, divide by N. And now we want to store that into its new variable. So the store, right, it's just the store button down here across from the 1. So store that into, and I'm going to put mine back in D. So alpha, and there's my D. Okay. So now let's go ahead and initialize our S. So we're going to put 0 and store it into S. I'm going to let S be my sum again, just like I did before. And if you don't zero it out, then whatever you had in there the last time, it might still be there. Your calculator is not automatically going to zero it out. These other letters are going to get reassigned as soon as somebody puts in a new value. Same thing with D. As soon as you do your new calculation, D gets replaced. So we just need to make sure we're starting fresh with S. Okay, now something about the trapezoid rule, right? It's a little bit different in that I have two values, right? F of A and F of B only happen once, but all of those middle ones happen twice. So I'm going to do my F of A and F of B independently, and then I will do each of these as a for loop, right? All of those interior ones as a for loop. So the first thing I need to do is I need to put my value of A into X. So I'm going to take A and put it into X, and I'm going to use my X vars here so that the calculator knows that, oh yeah, this is a variable. When I tell you Y1, plug that particular X value into it. So let's go ahead and do that. So Y1 we find under this vars button right by your clear. So vars, Y vars function, enter. So Y1, it's going to take that last X value, and then what we want to do is we want to add this to S, and I know S is 0 right now, but we're just getting into the habit, and then we're going to store that back into S. So S is just our running total. Okay. So now I found F of A. So now we're going to find F of B. So we're going to take the variable that's in B, right, that value, we're going to store it into X, and then we're going to find Y of, so vars, Y vars function Y1. So now it's going to take its new X value, which is the B value. We're going to add it onto S, right? So S is tallying up its stuff, and store it back in S. Okay, so now I have those first two. Or, I'm sorry, I have the first one and the last one. I have f of a and f of b. Okay, so the next thing we want to do is that middle one. So you need to find 2 times f of x sub 1 plus 2 times f of x sub 2, etc., all the way out to f of x sub n minus 1. Okay, so now let's do that for loop. So program down to the 4, so 4 comma. Now there are different ways you can do the loops. You can do an if-then, you can do a while, you can do a repeat, but I'm going to do the 4. So 4, I'm going to let j be my dummy variable again. So for j, hold on, delete, for j from 1 to n minus 1, right? So I need to stop at n minus 1. N minus 1. I'm going to have my calculator do this next thing, right? So we're going to calculate, first let's get our x value, right? So that's going to be a plus j times delta x, right? J times, and it takes me forever to find these. So here are my new x values. So the first one, right, will be at 1 full step away from, right? So j is going to be 1 on my first one. So you're going to start at a, and you're going to do 1 delta x step. And you're going to do, for your next x value, it would be 2 delta x steps. Okay, we're going to store this into our x. We're going to evaluate y at it, but remember I need 2 times y. So we'll do 2 times y sub 1. We're going to add that into our S that's holding our sums, and then store that back into S. Okay, so that's doing, these 3 lines are doing that middle, right, all of those 2 times f of x sub i's. Okay, and now we have to end it. So program, and then down to item 7, end. Okay, so there's my for loop. And enter, enter, and we're done. So, well, we're almost done. So the next thing we have to do, so S is holding everything in my brackets. So the next thing I need to do is multiply it by 1/2 times delta x. So we will let, well, let's just do that. And we can just display the answer, I suppose. We don't need to do anything pretty. So let's go ahead and do program, and this is an output, and we're going to display, so item 3, and I need S times delta x, which is in D, and then times 0.5. And you could say some, if you want to type any words in there, then you can, but you don't have to. Okay, I think we're done. Let's go ahead and give it a shot. And again, I know what my answer is, so if it's not right, we'll come back and we'll try to debug our program. So we'll quit, and then program, and we're going to execute the trapezoid rule. Yes, there's our clear screen, and asks for n, so we'll do n equals 8. Again, starting at 1, ending at 5, and that's what we were looking for. So now that you have your program, right, you could change your n value. So let's rerun it with a bigger n, and we would expect, right, the approximation to get even better. And just so that you know, right, so here was my, in y1, there's that 1 over x cubed. So you need to put the function that you're using into your y1 screen, because that's how we have it set up. If you didn't want to use y1 because you want to have that for something special, you can make it be y7 or something, one of those y equals that you don't usually get to. Okay? So if I did this with a larger n value, maybe 12, right, we would expect our approximation to get better and better the more, right, intervals that you take. So that's how you can program the trapezoid rule into your calculator.